Hey, welcome to lesson 4.7, Applications of Similarity. What we're going to be doing is taking all of these things you've learned about similarity and applying it to word problems. So for those of you brave enough to do it, I respect you. Let's get into it. So two ladders, one 12 feet long and the other 20 feet long, are leaned up against the wall and make the same angle with the ground. The shorter ladder reaches up 9 feet to the wall. How far will the longer ladder reach up the wall? Now, this is a word problem that's going to involve similarity, and I'll show you why. But before we even get started, we're going to just draw some pictures. All right? So we know we have two ladders, and they're leaning up against the wall. Let's see if we can draw that. Well, hopefully you can do this better than I can, but that's my ground. That's so bad. That is the worst ground ever. That's my ground. Let's say that this is my wall, and here are going to be my two triangles. I got triangle 1. This is my longer ladder, and this is my triangle 2. This is my shorter ladder. Okay? God, that's so bad looking. Urgh. Now, what it tells us is that they make the same angle with the ground. So I know that these two angles are congruent. They make this angle with the ground. And they both actually have this right angle right there. So if you see this, these are two similar triangles because they both have two angles in common. They have these two angles, and they both have this 90-degree angle with the wall. So these two triangles that we formed are similar. Now, let's set up what we know. We know one is 12 feet long and one's 20 feet long. So our shorter one is 12 feet long and our longer one is 20 feet long. Okay? The shorter ladder is reaching 9 feet up the wall. So this shorter ladder right here, this is making a 9-foot. It's going 9 feet up the wall. What we want to know is how far up the wall this guy is going. All right? Well, this looks pretty straightforward to me, right? We're just going to set up our ratios. I know that 12, oh sorry, it's always bigger over small. I know that the length of my ladder, this 20 over 12 is going to be equal to my x, which is this length right here up the wall, over 9, which is shorter. All right, I'm just doing my corresponding parts. 20 is to 12 as x is to 9. We cross multiply, we get 180 is equal to 12x. Divide both sides by 12, and we get x is equal to 15. Okay, so how far up the walls are going? The 20-foot ladder is 15 feet up the wall. So the real key to doing these is drawing a nice picture. Better than I can because I'm not good at drawing pictures, and then just solving it out. In this case, the width of the river, to find the width of a river, and this is actually true, this is how they find the width of rivers. Jordan surveys the area and finds the following measures. Find the width of the river. Well, if you see here, clearly they're giving you two similar triangles here. You have a 90-degree angle here, and you have a 90-degree angle here. And if you see this, these are vertical angles, so we could say those are congruent. So this is angle-angle similarity. All right? Now that I know these two triangles similarity because of my angle-angle similarity, we just got to set up some ratios. So what it looks like is that these two are my corresponding sides, and since I'm looking for the width of the river, this will be my x. So let's set up some ratios. I know that 79.6 is to 34.2, which is equal to, once again I'm going to start with my bigger triangle, x is to 18.6. Let's cross multiply these. I get 34.2x is equal to, let's grab a calculator, 1480.56. Okay? We're just going to divide both sides by 34.2. And let's see what we get. 34.2. Do my division. X is equal to 43.29, and it keeps going, so I'm just going to stop it right there at the 100th. That is my answer. 43.29. All right. Looks good. Let's keep rocking. In this question, and this is the most typical one you'll see when they talk about shadows, in this question it says a 3-foot pole in the ground casts a shadow of 4.5 feet long. What is the height of a tree which casts a shadow 30 feet long? All right, The way we're going to do this is we're going to draw our pole and our tree. So let's start with our pole. Here's our nice little pole in the ground. It's 3 feet high. All right. And then we have our tree. All right. And that's my beautiful tree. That's in the ground. And it's asking for the height, so let's put an X there because we don't know how high my tree is. All right. So we got our 3-foot pole cast in the ground, and we got our tree. All right, which we don't know the height of. Well, now the additional information is it says the pole casts a shadow 4.5 feet long. So this casts a shadow like this, and this is 4.5 feet, this distance right here. Okay, that's the height of the shadow. The tree casts a shadow 30 feet long. So my tree, which starts here, well, when this casts a shadow, it is 30 feet long. Okay? 4.5, this is 30, and I'm trying to find the height of this tree. Well, actually, you'll see here that now I have two similar triangles. How? Well, they both share this angle, and these are both 90-degree angles, right? The tree makes a 90-degree angle, and that makes a 90-degree angle. So I have my two similar triangles now. And basically what I could do is set up my ratio as this. My tree, the height of my tree over the height of my pole, which is 3, is equal to the length of the shadow of my tree, which is 30, over the length of the shadow of my pole. Well, now I just cross multiply. I get 4.5x is equal to 90. Divide both sides by 4.5, and I get x is equal to 20. Beautiful work. All right, for our final problem, this is the challenge problem, okay? Let's give it a shot. On level ground, the base of a tree is 20 feet from the bottom of a flagpole with a height of 48 feet. Ooh, that's a tough one already. So on level ground, which is my level ground's right here. I'm going to try this one more time. Okay, the base of a tree, which is, let's draw our tree now, is 20 feet from the bottom of a flagpole. So this is my flagpole, okay? This is my flagpole. These have a distance of 20 feet from each other, and this is 48 feet because my flagpole is 48 feet. The tree is shorter than the pole. Drew that already. At a certain time, their shadows end at the same point, 60 feet from the base of the flagpole. Okay, just like that. The shadows end at the same point, 60 feet from the base of the flagpole. So this distance right here is 60 feet. That's where our shadows are. How tall is the tree? Well, this is kind of a challenge problem, so I'm going to give you a second. Pause the video, see if you can figure it out. Take a minute, pause, then come back. I said pause! Okay, well, let's see if we can do this. So if we know the whole shadow is 60 feet, and this part right here is 20, then I know the distance from here, all right, where the shadows touch, to the tree is going to be 40. And I just do the 60 minus 20 to get that. 60 minus 20. All right, so that's my first triangle right here. All right, and since we're trying to find the height of the tree, let's put an X there. Now my bigger triangle is this guy right here. I got this bigger triangle from the flagpole, right? But this one I know. I know the height is 48 and the shadow is 60 feet. So now I can just set up my ratio. The height of my flagpole, which is 48, over the height of my tree, which is X, is equal to the length of my shadow, which is 60, over the length of my tree shadow, which is 40. Now we just do a little cross multiplication. We get 60x is equal to, I got to take out my calculator because I can't do that in my head, 40 times 48, and I get 1920. Oh, I forgot my x over here. Divide both sides by 60, and I get x equals 32. So the height of my tree is 32. Alright guys, so if it's ever a shadow question or a ladder question, you know it's going to be similar triangles. Shadows and ladders are similar triangle questions. Remember to step 1, draw it out, label the picture, and then set up your ratios. Alright, good luck.